Hello everyone, Ramya, Assistant Professor of CSE Department from Rohini College of Engineering and Technology, subject code CS3352, Foundations of Data Science, Unit 4, topic Aggregations, Computation on Arrays. Aggregation means max and everything in between, minimum and maximum. Python has built-in minimum and maximum functions. It is used to find the minimum value and maximum value of any given array. For minimum, maximum, sum and several other NumPy aggregates, a shorter syntax is to use methods of the array object itself. np.min means it is used to find the minimum value in the array. np.max means it is used to find the maximum value in the array. For example, x is equal to 1, 2, 3, 4 means suppose if you want to find the minimum value means you have to use the syntax np.min of x. X represents the array name. So your one value will be given as a result. Likewise, np.max of x means in the given set of array, which one is the maximum value, that value will be written. Here the 4 value as a maximum. The next one is your multi-dimensional aggregates. One common type of aggregation operation is an aggregate along a row or column. By default, each NumPy aggregation function will return the aggregate over the entire array. That is, if we use the np.sum, it will calculate the sum of all elements of the array. For example, m equal to np.random of 3, 4. That means it represents 3 rows, 4 columns. Here, if first inside the array, what are the values if we have? So, if in this example program, you are going to find out the sum value. So, you have to do is m.sum function. It will add all the values having inside the array and you will get one answer. That aggregate functions take an additional argument specifying the access along with the aggregate is computed. Now we are going to see some other aggregate functions. That means NumPy provides many other aggregate functions, and most aggregates have a NaN safe counterpart that computes the result while ignoring the missing values. In this tabular column, it shows the function name, NaN safe version description, np.sum, np.product, np.mean, np.standard. That means you are going to find out the sum of elements, product of elements, median of elements, and then you want to compute standard deviation. Means you have to use the particular syntax, then only it will get the particular answers. The next one is computation on arrays broadcasting. Broadcasting is a simply sized binary operations are performed to a set of rules for applying binary function. That means addition, subtraction, multiplication, etc. on arrays of different sizes. Here in this diagram, it shows the different sizes of the array broadcasting. That means suppose if you are using one dimensional array means structured or broadcast. Otherwise you are going to use the second dimension in order to match the shape of M. Likewise you have to do the aggregation function. Likewise for example, if you are going for the one dimensional, in this one dimensional array how many rows and how many columns if you want, you can specify that. Likewise two dimensional array, three dimensional array, you have to adjust. We have to stretch or broadcast one value to match the shape of the other. So only we have to stretch both A and B to match a common shape, the resultant in the two-dimensional array. Next we are going to see some rules of broadcasting. Broadcasting is a NumPy follows a strict set of rules to determine the interaction between the two strings. Rule number 1, if the two arrays differ in their number of dimensions, the shape of the one with fewer dimension is padded with ones on its leading side. Next, rule number 2, if the shape of the two arrays does not match in any dimension, the array with the shape equal to 1 in that dimension is stretched to the match the other shape. Rule number 3, if any dimension the sizes disagree and neither it is equal to 1, an error is raised. Thank you.